Good morning. Oh, I already see people saying hi. Let me know if you can hear me because I dropped my microphone when I was coming here. I'm just gonna respond hi to everyone. Hi to my digital pathology trailblazers. Okay, I had a little bit of trouble connecting today. So if you are here and you can hear me well, I'm just gonna check the microphone settings, microphone. Okay, I think it's working. You let me know if you don't hear me, and let's do it. Welcome, my digital pathology trailblazers, to the 20th DigiPath Digest. We've been meeting for 20 weeks. I'm so proud of us because every time I see you online, now you should hear me. Okay, so if you are here, let me please know that you're here and where you're tuning in from. And we're gonna start reviewing those papers before I lose my connection again. So we're gonna go fast today. I titled the, oh no. Oh, wait, guys. Okay. Oh, good. I titled the live stream today the evolution or the evolving role of liver biopsy, even though it was not the first paper. It was the 7th on my list. But current applications and future prospects. I was like, is the liver biopsy going to disappear? Like, will we not do liver biopsy? That is not the case. But I chose this one because I actually, a year ago, I had a consultation with a person who wanted to influence the regulatory bodies not to require a liver biopsy for a particular, I think it was the metabolic associated liver steatosis or something like that. And then I saw this paper and I'm like, oh, did they achieve that? It's not the paper of this person. This paper is from, let's see, can I draw? Yeah. And this is in hepatology communication group from Texas and Hershey, Pennsylvania. I used to live near Hershey. That's why I'm so happy about that. Okay, I see more people joining. Give me a hi in the chat and let me know where you're tuning in from. And we had some trouble connecting today. That's why we are later than usual. But going back to this biopsy. So, this group from Texas, Hershey, Pennsylvania, and New Haven, Connecticut, what they are saying here is that the utility of liver biopsy has been questioned by some. And I know it has because I was talking to a person. And when I was talking to them, I was like, no way will they like ever abandon. He was mentioning some kind of other imaging technique like very high resolution MRI or I'm not sure, not ultrasound. But anyway, it has been questioned, right? And given the improved imaging modalities, increased availability of non-invasive serologic tests, and development of AI over the past several years, And they, in this review, say that what is the role of the biopsy? Shall we even have it? And I was happy to read that, yes, we shall have it still, but not for everything. So for unknown, so if there is a test for a disease that can confirm this disease without, sorry, I'm trying to switch my view. Everything is failing me today. No, I have to stay positive. We stay positive. Okay, and we have people from Portugal. Welcome. And LinkedIn people saying hi. Thank you so much. YouTube people saying hi. Thank you so much. So the deal with the liver biopsy is, if there is a test, a different test than histopathology that can confirm a disease, serological or imaging test, including ultrasound, whatever, or some like imaging biomarkers in the non-pathology space, then you don't have to do the biopsy. And this is the stand of here, the American Association of the Study of Liver Disease, and this is published on their behalf. So basically they are communicating, hey, you don't need to do a biopsy if there is another way to confirm the disease. But if there is no way to confirm the disease, or if it's in the early stages, because for example, for this one that is associated with metabolic associated liver steatosis, that is in the later stages, you can see it with imaging. But in the earlier stages, it's not possible, but you may already have some symptoms or some liver parameters that are altered, and then you do need a biopsy. And what should you do? You should do whole slide imaging and leverage image analysis to be able to sorry, let me do this again. Leverage image analysis here, I wrote it for you, to have a better way of quantifying, and maybe to also use AI, and but mostly for better quantification, because all those scores for steatosis are usually semi-quantitative, often relying on special stains and on something that's going to be visually challenging. You're going to state the presence, it's there, but if you need to quantify the area of liver that is covered by fat or by vacuoles, or how much fibrosis, that's already more challenging. So when possible, use image analysis. And I am so happy that American Association for Study of Liver Diseases said that. Thank you so much. And thank you so much for joining, even though we had to change the time last minute. So I'm grateful for that. So let's go back to the beginning. Let's scroll back to the beginning. I just thought this liver biopsy, it kind of like gave me I wasn't scared, but I was like, oh, but pathology is always invasive. Is there gonna be a technology that's gonna be non-invasive and you will not need it anymore? I don't think for everything. And yeah, we still will use pathology for different things, but obviously the less invasive and the less troublesome for the patient that is, the better method that's what's guiding these guidelines. So let's go back to our papers. And if you have any questions, regardless whether it's related to the papers or any digital pathology questions, let me know in the chat, because I don't have enough questions yet to like start those live streams, but I will be starting Q&A live streams once a month, or maybe later if we gain some momentum and there's more questions coming in once a week. But definitely drop your questions in the chat and let me know what you're interested in. If it's related to those papers, or if we have time, I will answer right now. And if not, I'm gonna keep. I have already started a spreadsheet with questions, so all your questions are landing there, and then will be answered in the live streams. And now let's talk about deep learning-based lymph node metastasis status predicts prognosis from muscle-invasive bladder cancer histopathology. World Journal of Urology with the impact factor of 2.7. And this group is from Wuhan, China. Anywhere else? No, everything from China, from Wuhan. Okay, so the purpose here was to develop a deep learning model based on primary tumor tissue to predict the lymph node metastasis status of muscle-invasive bladder cancer, MIBC, which I was, that was like, it's the other way around. You see the tumor and you kind of like predict if it has metastasis in the lymph nodes. And apparently you can do it. I was surprised, but you can. So while validating the prognostic value of predicting AIN score in MIBC, so AIN is the score that predicts the probability of the metastasis, and they had 323 patients from the Cancer Genome Atlas. So they took slides from the Cancer Genome Atlas, training and internal validation set with image features extracted, and they used the visual encoder UNI. So if you remember me talking about UNI, maybe you've seen the social media post where I was analyzing my earrings with UNI and conch at one conference at the Lumea Diagnostic Summit, Digital Diagnostic Summit. So I'm familiar with UNI. And in the external validation, they was conducted on 139 patients from Renmin Hospital of Wuhan University. And what were their results? Area under their receiver operating characteristic curve of 0.79 in the internal validation and 0.72 in the external validation. And then also this score emerged as an independent predictor, this AIN score, independent predictor of survival for the muscle-invasive bladder cancer patient with a hazard ratio of 1.608 in the TCGA cohort and 2.746 in their hospital cohort. So survival, predictor of survival, and this hazard ratio is okay. If it's 1.6, then something is 1.6 times more likely to happen than the other thing, right? And the conclusion is that image analysis showed promising results, directly extracting relevant prognostic information from H&E stain histology to predict the LNM status, lymph node metastasis status, of muscle-invasive bladder cancer patients. So this is interesting. More and more of those biomarkers based on images, more and more predictive biomarkers, which is good. Then this was funny. This is author correction predicting the tumor microenvironment composition and immunotherapy responses in non-small cell lung cancer from digital histopathology. And I was expecting some like big correction and like something happening there that they did something wrong and then they had to correct it. No, they had to correct the author. Prashant Ashok Kumar was previously Prashant A. Kumar, and they wanted to correct that. So, and I don't remember us talking about this paper, and it's not really included in our abstract, but I will include it in our next session, or I will make a separate video about this because it's interesting and it's in the one of those Nature journal. Nature, like this family of Nature journals. So sorry for not doing it now, but we will do it at some other point. I crossed out the stuff that's not relevant for us. What else do we have? Our biopsy we already discussed. Okay. This one. Let's do it together. I partially did it ahead of time. HistoNext dual mechanism feature pyramid network for cell nuclear segmentation and classification. Interesting. Let me know if you have any questions. And I see people rejoining. Hello. Let me know where you're tuning in from. So this is BMC Medical Imaging, and this is a group from China, Shanghai. Everybody from that group. And they wanted to develop an end-to-end convolution network model for analyzing H&E stained histological images. Let me do this one. Enhancing the performance and efficiency of nuclear segmentation and classification within the digital pathology workflow, which kind of makes me ask the question, what do you want segmentation and classification in the pathology workflow for? Like, what's the underlying task? Because for pathologists, you don't really need to do this segmentation. So we will probably learn. We propose a dual mechanism feature pyramid fusion technique that integrates nuclear segmentation and classification tasks to construct the HistoNext network model. So this model, HistoNext, utilizes an encoder-decoder architecture. So this is encoder-decoder is an architecture similar to the what's the architecture? Transformer, and the transformers from that we know from the large language model. Yes, where the encoders based on advanced ConvNext convolution framework efficiently and accurately extracts multi-level abstract features from tissue images. These features then are shared with the decoder. The decoder employs a dual mechanism architecture. So the first branch of this mechanism splits into parallel paths for nuclear segmentation, producing nuclear pixel and horizontal and vertical distance predictions, while the second mechanism branch focuses on type prediction. So nuclear pixel, horizontal, vertical branches leverage densely connected blocks to facilitate layer by layer feature transmission and reuse, while the type prediction employs channel annotation to adaptively focus on critical features. Honestly, that's a lot of computer vision speech that I'm not sure if I understand correctly. We'll see. And welcome to Nigeria. So then also they employed comprehensive data augmentation, including morphology, preserving geometric transformation, and adaptive H&E channel adjustment. So what is this data augmentation is basically for the computer just sees the pixels, and if you want to make more data out of less data, you kind of transform the pixels. So for example, if let's take my mouse. If we see the mouse like this, and we want to make more data out of this one image of the mouse, then we're going to image the mouse like this, like this, like this, basically rotating, and you see this with mitotic figures or different things. And for the computer, each representation of this mouse in a different position is gonna be like a different data point. For us, like, it doesn't matter where I put this mouse, it's a mouse. For the computer, in the computer vision world, you do this data augmentation, and they said morphology preserving. So morphology non-preserving, you can like stretch it, shrink it, and different things that basically like alters visually its shape. But preserving, it's gonna maybe be rotation or like moving it somehow. And also they did the color adjustment. They also wanted to address imbalance with type-aware sampling, and the model was evaluated on public tissue image data sets and they mentioned different data sets, concept, PanNuke, CPM17, I don't know these data sets, but that's okay. And the performance was evaluated using the dice coefficient, the aggregated Jacquard index, and panoptic quality. And it was also evaluated, performance was evaluated using F1 scores and category-specific F1 scores. And so let's see, what were the results? Our results were that HistoNext demonstrated competitive performance across multiple data sets. We had a DICE score of 0.874, AGI of 0.72, PQ of 0.689, and CPM7 on the CPM 17 data set. And then they go through how good it was on the other data sets. And the conclusion is, by integrating novel convolutional technology and employing a pyramidal fusion of dual mechanism characteristics, HistoNext enhances both the precision and efficiency of nuclear segmentation and classification. Its low computational complexity makes the model well suited for local deployment. This is important, even if it's a very computational heavy paper. A low computational complexity makes the model well suited for local deployment. So there is this discussion going on in the digital pathology community, because we generate a lot of images, and those images are big. So you need to store them, you need to somehow process them. And so the discussion is between on-prem versus cloud computing. And cloud computing gives you access to bigger resources, but it has bigger latency because it's cloud and not on-prem. On-premise, you need a powerful computer. So the ideal and the direction where these models, these huge models that are trained on millions of images, would be deployable was to streamline them, to make them lean, and lean in terms in the computer, in the software development sense of this word, so that they are not computationally heavy, that they can run on a not so powerful machine, they can run locally, so that you can basically deploy it to the world, and not just to those who have a very sophisticated and powerful computational infrastructure, including access to the cloud. They're not lean yet, but we have some that are performing well. So the next step maybe would be to make them lean. I don't know if you can do it in software development. If you know more than me about software development, let me know if you can make a lean model out of an unlean model. What I've been seeing, like a trend I've been seeing was, okay, you develop something on whole slide images, and there's a whole, a lot of people, a lot of pathology practices, a lot of pathologists that don't have access to whole slide images. So are you then depriving those people, those patients, from the advancements that you gained on whole slide images? Well, not necessarily, because now those models and those programs developed on whole slide images can actually be applied to static images. So you have the model that can actually run on a static image, and most of the pathology places either have or can have access to a microscope camera, because they do have access to microscope. So I see this like going from cumbersome and developed on technologies that are not accessible to everyone, being then moved forward to technologies that are more accessible and less computationally heavy. So I'm kind of hoping that those exercises with developing those more lean models are bringing us in that direction. So yeah, local deployment in resource-constrained environments, thereby supporting broad spectrum of clinical and research application. This represents a significant advance in the application of convolutional neural networks in digital pathology analysis. So We did not learn why they wanted to do the segmentation and classification, but we did learn that they did it in a more streamlined and computationally, what do they call it? Not complex, so not uncomplex. And yeah, and we have a question. Question is, I hold a master's in oncology and I'm keen on pursuing career in pathology imaging. Thank you so much for the kind words. The best way to contact me is to get on my email list. So if you go to the Digital Pathology Place website, let me say, Digital Pathology Place. I'm going to share it with you in 1 second. But basically, if you want to get in touch with me, there are 2 ways. We are connected on LinkedIn, and you can send me a LinkedIn message, or let me share this. Go to my website, present. Put this screen, present, share screen. You go to my website, and then you're going to find this little button, Digital Pathology One-on-One ebook, which I will be updating soon. So if you don't have it, then go grab it on my website. And if you have it already, then you will already get, everybody who downloaded it will get the updated version when it's going to be updated, because a lot has happened in the AI space. So I definitely want to update this chapter, and I want to add some other cool chapters with a chapter with stories from maybe my podcast guests and different inspirational things as well. So when you go there and you get my book, then you're going to be on my email list. And when you're on my email list, you can send me emails. And I answer them. I'm like hesitating because sometimes I lag in answering, but usually I do. So go ahead, grab the book, and I wish you the best of success for pursuing a career in this space. And thank you so much for joining me. Even though we had a little bit of hurdles, I wish you a fantastic weekend, and I talk to you in the next episode. Bye. Don't forget to leave me the questions. Even if you're watching the replay, be sure to drop the questions in the LinkedIn or wherever you're watching this comments, because I'm gonna be collecting them in a spreadsheet in a special folder with questions, and I'm gonna be hosting Q&A soon. Let's see if we can gather enough questions for February, and I would start doing this in February. Bye.